Cheloskis, everybody! In this video I'm going to be talking to you about right triangle trigonometry. I didn't spell out trigonometry because it's a long word and I'm a math teacher, but it is spelled Trigonometry. Trigonometry. Yay! So I'm going to draw a triangle since this is what we are dealing with. Yay, I made a triangle. So with this, notice we have these right triangles. This is called theta. Theta, circle with squiggly happy man. This is theta. Theta is a Greek symbol. We use it for the angle many times. It's kind of common. What we have in this, to label this right triangle, we have the hypotenuse, right? We have the side across from the angle is the side opposite, ITE, and then the side right next to it, touching the angle but not the hypotenuse, is called the adjacent side. Adjacent. And we have trig functions that talk about the ratios of the sides, and they are called these. So these are all of our trig ratios. Sine, this is sine. This is not sin. Do not say sin, or you will, I don't know, whatever. This is called sine of theta. It is the opposite side over the hypotenuse side, whatever those may be. This one is cosine, which is adjacent over hypotenuse. This one is tangent, which is opposite over adjacent. Now, these are the new ones for you guys. You saw these ones in geometry. Hopefully you remember them. If not, that's okay. You can get the opportunity right now to remember them, or go look up some other stuff. This one kind of goes with sine, because notice they're just like the opposite. They're reciprocals of each other. So this one is called cosecant. This one is called secant. And this one is called cotangent. The way that I remember that these two go together is S cannot go with another S. So S goes with C, S goes with C, and then cotangent and tangent because they both have T's in there. I don't know. Okay, so we're going to be messing with these ratios and dealing with triangles and finding new ratios and solving triangles using these ratios. Ratios? Okay, so this is one type of example you will see. What example? This example. Crazy kid. Okay, where you're finding the values of the 6 trig functions, so the ones that we just listed, and that's all we're going to be listing. So I'm going to go ahead and write them out real quick. Alrighty, and something I didn't talk about up here is don't forget about SOHCAHTOA. SOHCAHTOA in water. Kind of helps you remember the ratios because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it just helps you remember what they go in. I always write that at the top of a quiz or a test that I'm taking. So sine, I know, is opposite over adjacent. Or sorry, over hypotenuse, ignore that. So there's my angle right there. The opposite side, if you want to label it, would be this. The adjacent is right there and the hypotenuse is there. And then it's just a matter of substituting those numbers in. So opposite over hypotenuse is 12 over 37. And then cosine's adjacent over hypotenuse, so 35 over 37. And I don't want that color. Tangent's opposite over adjacent, so 12 over 35. And then I know that these are just the reciprocals of those numbers because I memorized that they are the reciprocals. If you do not memorize anything in this unit, you will fail. Tough love. But you will. Just like you would fail anything before. But really, especially with this unit, you can't just kind of guess your way out of it. You really have to know this stuff. So welcome to pre-cal. Yay! Alright, here we go. Doing another one. Yeah. This one I'm given cosecant, so I can at least say that sine of theta is equal to 1/6, right? Because this is the reciprocal. So then if I know that sine is 1/6, then I can draw a triangle such that from my angle I have opposite over hypotenuse. And then to find the last angle, I can just use Pythagorean Theorem. So a squared plus b squared equals c squared. So 36 equals a squared plus 1 squared. So 35 is a squared. A is the square root of 35. Yay. So square root 35. And then it's just a matter of listing your ratios from there. If you don't know Pythagorean Theorem, look up a video about Pythagorean Theorem. You've been doing it since like the 6th or 7th grade. So from this point on, I'm just going to write a number there. And I will tell you that I'm using Pythagorean Theorem, but make sure you know how to use Pythagorean Theorem. If you don't, you'll also fail. Okay, so there are the other 4 listed out. Cosine is adjacent over hypotenuse, so root 35 over 6. and this would be 6 over root 35. We're not going to worry about making you guys simplify this. Tangent's opposite over adjacent, so 1 over root 35, and this would just be root 35 then. Cool. All right, with a problem like this, find the value of x. I know that x is my hypotenuse, and I'm given my opposite side, and I'm given an angle. Well, if I know my opposite side, trying to find my hypotenuse, the ratio that would probably help us is sine, because it is opposite over hypotenuse. So I can say sine of my angle is sine of 18 degrees equals opposite, which is 9, over the hypotenuse, which is x. Well, now it's just algebra 1 stuff. If I multiply by x on both sides, and then I can just divide by sine 18. And then it's just a matter of punching that in your calculator. So 9 divided by sine 18. So x should be 29.125. So x equals 29.125. It is a side length, and I'm not given any measurements, so I don't have to put anything else. Happy day. All right, this is another one where we want to find the value of x. This time I'm given the adjacent side. I'm also given the hypotenuse and an angle. So I can say cosine of my angle is 20 degrees equals adjacent x over hypotenuse 12. So in this one, all I have to do is multiply by 12 on both sides and plug in my calculator, 12 cosine 20. And that would be 11.276. So x equals 11.276. Cool. Okay, now we're doing something a little bit different, finding the value of our angle. And this one I'm given my opposite, I'm given my hypotenuse, so again I can use sine. I can say sine of my angle is equal to 12 over 27. Well, just like we do in matrices, if you guys have seen matrices before, we have to do something called the inverse function. So if I take sine inverse of both sides, that gets rid of sine, so I have theta equals sine inverse of 12 over 27. Biggest thing about this, make sure all I'm looking for in my calculator is right above sine. There we go. There's a button that says sine inverse. If you are looking for your angle, make sure that your mode is in degrees. So if you hit the button mode, it will take you to a screen like this. So make sure you are in degrees. Degrees, and degrees is highlighted. Then all you have to do is hit sine inverse 12 divided by 27, and it will give you your angle. Yay, magic. 26.388. Theta equals 26.388. It's an angle, so make sure you give me a degree sign. Yay. All right, doing the same thing here as we were in the last one, except this time I'm given my opposite and I've given my adjacent, so I can say tangent of my angle is opposite over adjacent, and then just do tangent inverse in my calculator. Think it was 9 over 8, and then it is 48.366. Yeah! 48.366 degrees. Yay! Oh yeah. Theta equals. Yes. Okay, in this one, if they say solve the right triangle, you are looking for all of the missing components. So the only things that I don't know here is little b. I don't know big B. I don't know big C. If they are big, they are talking about the angles. Little b is talking about that side length. But in the side lengths, I know 30 and I know 7, so I can use Pythagorean Theorem to do 900 minus 49, take the square root of 851. I don't know if it's an actual number. It's not. But this is about 29.17. You can also leave this square root 851 for me. I am cool with that. Pre-AP, you're probably not. So make sure you do what you need to do there. Then I need an angle. But since I found this side by myself, what I can do is use the other two measurements that were given just in case that I did this wrong, such that I will still get angle B and angle C correct. So it doesn't matter which one you find. I'll just find angle C first, since I have sine of C equals opposite over hypotenuse. So I'm going to do sine inverse of 7 over 30 and get C is 13.493 degrees. And well, if triangles add up to 180 degrees, then I can do 90 minus that angle, since I already have 90 taken up with my right angle, and find out that angle B is equal to mental math 76.507 degrees. There we go. We've solved the triangle. So mathematicians throughout the years have come up with these special right triangles that as long as these angles are this, the ratio of the sides are as follows. So for your 45, 45, 90, it is 1, 1 square root 2. For your 30, 60, 90, across from the 30 is your smallest side length, which is 1. Across from your 90 is your longest side length in that, which is 2. And across from 60 is your square root 3, which is really 1.732. So it's right in the middle, so you put square root 3 right in the middle. Memorize, 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 to the infinite power, memorize. Make sure you know these. You'll be using them from now until almost the end of pre-cal, and really even on your final. But seriously, like, these are way important. I can't stress to you enough how badly you need to memorize these and where everything goes in them. If you don't memorize, I've said it like 4 times this video, you're going to fail. This chapter is super important. 4.1 through 4.3, if you don't understand it, you're going to have a really, really rough time all the way through chapter 8. So make sure you do this. I really don't ever preach to you guys like this, but make sure you do this. Please, these next 3 sections will make or break your pre-cal experience. Make sure you listen to me, heed my advice, memorize everything about 4.1 through 4.3. I promise you, you will do much better if you do. If you don't, you're bad, it's on you. Make some note cards. Do this. I love you guys though. You guys are really awesome. Just do that for me and we will be best of buds. Because then it makes ones like these super, super simple. Because then cosine of 45 degrees, well, hey, I know my special right triangle. From 45 degrees, adjacent over hypotenuse is 1 over square root 2, which simplifies to square root 2 over 2. Yay! Look at how easy that was. We're done. Memorize. And ones like this, sine of 30 degrees. I know sine is opposite over hypotenuse, so from my 30-degree angle, the opposite side is 1, the hypotenuse is 2. Yay, just from knowing my special right angles, I have that down. Sweet. Done. Ah! Oh no! I was being attacked. Pie was being thrown at my face. See, my face is all pie. Wah! You saw my face without seeing my face. All right, cotangent I know is the opposite of tangent, so this is adjacent over opposite from 60 degrees. So from my 60-degree angle, the adjacent is 1, the opposite is, square root 3, so 1 over square root 3, 1 over, 1 over root 3, which is the same thing as square root 3 over 3. Yay. If you don't know what I'm doing there to get that, rationalize this thing. 1 over root 3 times root 3 over root 3 is root 3 over 3. Yay. Make sure you know how to rationalize too. All right, one like this is also using your special right triangles. Later on you'll know that it's using your unit circle. So if I know tangent is opposite over adjacent, this is really 1 over 1. For the opposite side and adjacent side, opposite to be 1, adjacent to be 1, you had to go from 45 degrees, so theta is 45 degrees. Make sure you throw a degree sign on there if you're talking about an angle. Next one, I usually don't rapid fire, but these, just make sure you know your triangles. Tangent theta equals square root 3. There we go. Banana phone. Square root 3, which is really square root 3 over 1. So square root 3 is my opposites. 1 is my adjacent. So for the opposite to be square root 3, the adjacent to be 1, my angle must be 60 degrees. Yay. And here we go, another one, rapid fire. Boom, 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 it's coming at you. You can't catch it. You can't catch it. You're trying, but you can't catch it because it's in the digital space. You don't even know what I'm saying. I don't even know what I'm saying. I'm just making words come out of my mouth until I rewrite this thing. So this one was probably rationalized, so it probably came from 1 over square root 2, which means this is your opposite side. That's your hypotenuse. Since we are dealing with sine, you can't see that, but now you can. So for my opposite side to be 1, my hypotenuse to be square root 2, it looks like that would not work. From 45 degrees, opposite is 1, hypotenuse is square root 2, so theta equals 45 degrees. Yay, I did another problem. Yay, we're winners. We're not chicken dinners. We don't eat for dinner. No, you eat for dinner. I'm lying. Don't do that. That's not healthy for you. The last one, and then we are done for the videos. Cosine 1 over 2. Yay, yay. Why are you talking so monotone? Why are you talking so fast? What's wrong with you, Mr. Pike? I don't know. Yay, yay. Okay, cosine, adjacent over hypotenuse, adjacent, hypotenuse, so that must have come from my angle 60 degrees. Make sure you memorize these triangles. If you don't memorize these triangles, it makes all of this. Oh, there's nothing there. Monkey, monkey, monkey. Oh, monkey. Now there's a monkey there. It makes all of that a lot harder. So make sure you memorize your triangles. Yay, I know my triangles. And make sure you memorize the names of these and your new ones. Also, don't forget about SOHCAHTOA. Okay, those are the big things today. Do not call this sin. Please do not call that sin. That is not sin. That is sign. Sign. I saw the sign. There's a song about it somewhere. Listen to it. Love you guys. Peace out. Bye-bye.